Hello students, welcome to today's lecture. We want to discuss the effect of impurities on steel, the effect of impurities like silicon, sulfur, manganese and phosphorus that we discussed in our last lecture. And now we'll start with the effect of silicon. So if we add silicon content in the finished steel, and normally the percentage of silicon that is recommended to be added in steel ranges between 0.05 to 0.3%. So the effect of adding silicon to steel is to prevent them from becoming porous. So it helps in removing the gases and the oxides. It prevents blowholes, thereby making steel tougher and harder. So what is the effect of adding sulfur? Sulfur makes the steel to be, it renders the steel so that it can be cut easily. So free cutting property in steel is given by the element sulfur. That's why we need to add sulfur together with carbon and iron to make steel. It is also found in steel either as iron sulfide or manganese sulfide. Iron sulfide, due to its low melting point, produces brittleness, whereas manganese sulfide does not affect so much. Therefore, manganese sulfide is less objectionable in steel than iron sulfide. What's the effect of having manganese? So manganese increases wear resistance of the steel. It increases steel hardness. It increases the strength of the steel and decreases machinability. It serves as a valuable deoxidizing and purifying agent in steel. Manganese also combines with sulfur and thereby decreasing the harmful effect of these elements remaining in the steel. So what is the effect of adding phosphorus impurity? So phosphorus, it introduces brittleness in the steel. It also produces cold shortness in steel. In low carbon steel, it raises the yield point and improves the resistance to atmospheric corrosion. So there are types of steels that are very important in the engineering field, and this type of steel, if you know them, then you can choose them or select them for proper application in the engineering field. So we'll start with the plain carbon steel. We'll talk about its composition and majorly its property. So plain carbon steel is an alloy of iron and carbon. It has good machinability and malleability. It is different from cast iron as regard to the percentage of the carbon present in it. It contains carbon from 0.06% to 1.5%, whereas cast iron possesses carbon from percentage of 1.8% to 4.2%. So plain carbon steels can be divided into the following types. One, we have dead carbon steel, and dead carbon steel has 0.15% of carbon. Low carbon or mild steel. The low carbon or mild steel has 0.15% to 0.45% of carbon. Then we have medium carbon steel, which has 0.45% to 0.8% of carbon. Then lastly, we have high carbon steel, which has 0.8% to 1.5% of carbon. The second type of steel is called the dead carbon steel. And this dead carbon steel possesses very low percentage of carbon, varying from 0.05 to 0.1 5%. It has high tensile strength that constitute up to 390 Newton per square millimeter, and the Brinell hardness goes to 115. It can be used as steel wire, as sheets, as rivets, as screws. It can be used in making pipes. It can be used for making nail and chain from this kind of steel material. So also this steel, the dead carbon steel, is useful in making the camshafts. It's useful in making sheet and strips for fan blades. It's useful in making welded tubing. It's useful in making forging equipments and materials. It's useful in making chains, stampings, rivets, nails, pipes, and automobile body. Students, this marks the end of our today's lecture. Let's meet again in the next class.